Hello. Ever wonder how an airplane doesn't just fall out of the sky? Ever wonder how a ping pong ball can stay suspended in the air with just a blow dryer? Yeah, neither do we. But in order to pass this class, we thought it might be important to find out. So with a little help from our friend Google, we discovered that it's due to something called Bernoulli's principle.
Daniel Bernoulli was born in the Netherlands in the year 1700 and was then raised in Switzerland. His family consisted of mainly mathematicians, including his father and two of his brothers. He attended Basel University, where he studied philosophy and logic, graduating at an astounding age of only 15. A year later, he received his master's in philosophy and logic. Upon request of his father, he then went on to receive a doctorate in medicine. In return for studying medicine, Bernoulli's father agreed to teach him mathematics. Bernoulli used this extensive scientific background to discover his principle in the year of 1738.
Bernoulli's principle states that with an increase in speed of a fluid comes a decrease in pressure. This equation is derived from the conservation of energy. The law of conservation of energy states that in a closed system, the total energy of a system is conserved. From this law, we can then determine that the sum of the total energy in a system must always remain equal, even if the final kinetic energy or potential energy differs. For this reason, if the kinetic energy increases, therefore increasing the velocity, the pressure must decrease as the potential energy will stay the same.
While it sounded great on paper, we weren't convinced, so we forced Armahn to put this theory to the test. We began by placing a ping pong ball in the flow of air dissipated by a hairdryer. As you can see in our experiment, the ball remains suspended above the hairdryer as one would suspect. However, it is not that the ball is simply being pushed up by the airflow as would be initially thought, but that it is instead being pulled upwards by the difference in velocity. This is seen when we rotate the hairdryer and ping pong ball to the side. If the stream of air created by the hairdryer were simply suspending it, the ball would fall as soon as it left the 90-degree angle. However, the ball remains suspended even when at an angle. How is this happening? When air flows around the ping pong ball, air moves faster over the top of the ball than the bottom of the ball. This difference in velocity leads to a pressure differential, with the area above the ping pong ball having a lower pressure than the area below the ping pong ball. This is why disturbing the airflow of air above the ping pong ball makes it fall to the ground.
While we now had seen Bernoulli's principle in action for ourselves, our question as to why airplanes are able to fly is still not yet answered. After some research, we determined that the secret lay in the shape of the airfoil or wing itself. Due to the shape of the wings, air flows over the top of a wing faster than on the bottom, creating an area of low pressure on the top of the wing. As we learned earlier, this then results in an area of high pressure on the underside of the wing. Because pressure flows from high to low, lift is created among the lift surface, in this case the airplane's wings, causing the plane to be able to fly.
Through optimizing lift capabilities of airplane wings through design, stall speeds are lowered. The stall speed of an aircraft is defined as the minimum speed at which below controlled flight is impossible. One example of this is seen in the graph of the stall speed for a Boeing 747-200. Upon graphing velocity and lift coefficient, a negative correlation is observed. This negative correlation means that increased lift results in a stall speed at a lower speed. Through designing an aircraft with low stall speeds, the overall safety of the aircraft is vastly increased as maneuvers and turns can be performed at a wider range of speeds. While higher speeds can easily be maintained in straight and level flight, it is essential that the plane not stall in the case of a strong headwind.
While many individuals may not be completely aware of the accomplishments of Bernoulli as they would Albert Einstein's or Isaac Newton's, his discoveries have led to groundbreaking innovations that may have otherwise not been discovered. Without this principle and subsequent research, flight would not be possible, therefore resulting in a vastly different world than the one we have come to know today.